Hi, and welcome back to the Division of Education, Innovation and Energy's e-learning program. I am Mr. Atwell, and today we'll be continuing with circle geometry. So the last time we were here, we looked at the various theorems involving circle geometry. We would have looked at the parts of the circles, we would have looked at the various theorems, and today we want to continue by applying these theorems to questions so that we can build our confidence in this subject area. You ready? Let's go. So let's start with this circle. Here, we see that we are given a circle and we're given many different letters that we have to find the angles for. Can you see any rule being applied to this particular question? Well, let's go again. We always start with the angle we know. And where is that angle? That angle is here. We know that this angle is 20 degrees. And what chord is subtending this angle? And how do we find that chord? We trace back our lines and we realize that if we were to trace back our lines, this is the chord that is subtending that angle. Now, if we look, we realize that E is also subtended by that same chord. And what is the rule? The rule is that any angle subtended at the circumference in the same segment by the same chord will have the same value. So if this angle is 20 degrees, it means that E will be equal to 20 degrees. Now remember, it's important to know why the answer is the answer and not just to know what the answer is. When it comes to answering your questions, many times you are required to write the reason for your answer. So it is not just to see, well, this will look like it's going to be 20 degrees, so then it's 20 degrees. You must be able to give a mathematical response as to why your answer is your answer. So let's continue. So we found E is 20 degrees. Excellent. Now let's move on. Let's erase all these extra lines and look again. So let's see if there are any other shapes that involve this angle. Well, what about this one? If we come here and we go all the way and we come up, what shape is that? Well, that is a triangle. Now, do we know any special thing about this triangle? Well, we see we have a line going from the circumference and going to another point on the circumference while passing through the center of the circle. Now, what is the special name given to that line? And as you would have seen in our classes before, this line is called the diameter. Now, if you do not remember the rules, I strongly recommend that you go onto the Division of Education, Innovation and Energy's website and review the lessons before. Because just practicing without having the foundation is not going to help you to grow in the way you need to. So let us continue. What is the rule that involves the diameter? Well, if the diameter subtends an angle at the circumference, then the angle subtended at the circumference is equal to 90 degrees. And what shape is this again? This is a triangle. And what do we know about a triangle? If we add up all of the interior angles in a triangle, the sum is 180 degrees. So if we know this angle is 90 and this angle is 20, can we determine what A is? But of course, 90 plus 20 is 110. That means that A would be the difference between 110 and 180 degrees. And the difference between those two numbers are 70 degrees. So it means that A has a value of 70 degrees. Now let's continue to move on. So let's just get rid of all of this working now because we've seen how to do this and we've seen what is involved in finding the answers. And what we're going to do is that we're just going to write all the values that we found on the next side across there so that when we're erasing, it will be easier to see what's going on. So far, we've seen that E is how much again? Right, 20 degrees. And we've seen that A is 70 degrees. So now let's continue. What else do we see here? What other shape do we see with the angles that we've found? Well, we see yet another triangle involving this 20 degrees, and it's this one. Now, is there anything special about the sides of this triangle? Do you realize that this side, because it's coming from center to circumference, this side will be the radius, which we're going to call R. And because this is coming from the center to the circumference, this side will also be a radius, which we're going to call R. Now, what kind of triangle has two sides that are the same length? An isosceles triangle. And what is the rule about isosceles triangles? The base angles will be the same. So if this angle is 20 degrees, this one is 20 degrees, which makes this angle how much? Well, 20 plus 20 is 40. And 180, take away 40, will give us 140. So it means that angle C will be 140 degrees. And why is that? That is because this shape is an isosceles triangle. So the base angles are equal, and the sum of the interior angles of a triangle always add up to 180 degrees. So now let's write in on our diagram what we have so far. And let's change the color from red, and let's put the answers that we found so far in blue. So here we have 70 degrees. Here we have 20 degrees. Here we have 140 degrees. Now what else do we have to find? We need to find B and D. Well, if you look at B in relation to C, we realize that both of these are on this diameter, which is a straight line. And what is the angle on a straight line? The angle on a straight line is 180 degrees. So what that means is that C and B will be supplementary angles, where their sum is 180 degrees. So if this entire thing is 180 degrees, and here is 140 degrees, then how much should B be? B should be 180, take away 140, B should be equal to 40 degrees. That leaves one more angle. And there are so many ways we could work this out. Remember what we said last time. There are various rules that can be applied. Not because I am applying these rules in this process means that this is the only process. It doesn't matter what rule you apply once it holds for the question. So we want to find this angle D. And we know this angle E. And we know that this is a triangle here. And based on what we've seen just now, what kind of triangle is this one? Again, this would be an isosceles triangle because from the center to the circumference is the radius. From the center to the circumference is the radius. And we know that for an isosceles triangle, the base angles are equal. So, if we know that this is 20, that means that D will be equal to 20 degrees. If you didn't want to do that method, you could have done this. Look at where these two angles are. A and D, if you were to join them together, are being formed or being subtended by this chord. And what kind of chord is that one? Because it's a chord that's going through the center, it's a diameter, which means that this angle here, subtended at the circumference, the total would have been 90 degrees. And if we found A was 70, then 90 take away 70 is still 20 degrees. So I did it a different method and I still got my answer because I applied the rules. Once you know the theorem, you apply the ones that are comfortable to you to solve the question. Not because I took a method means that you must use that exact method. Do not be afraid to see things differently from how I may have seen it. How about a next example? This one does not seem hard at all, does it? They just want to find the angles A and B, a very simple circle, and they tell us that this line AB is a tangent. Now, if they tell us it's a tangent, it means we must have to remember our rules that involve tangents. And what is one of the rules that involve tangents? If a tangent and a radius meet, the angle formed at that intersection is how much? 90 degrees. So automatically off the bat, just from knowing the rule, we know that this angle is 90 degrees. Now what about this one? Well, AOB, and if we were to trace it, so let me just erase all the extra things right now. Let's trace from A to O to B and back. That is a triangle. And again, the sum of the interior angles of a triangle is 180 degrees. So if here is 90, that means that these two angles together will be 90 plus 25, which is 115, which makes B the difference between 180 and 115. And by doing our calculations, we would realize that the angle is 65 degrees. Simple. How about another example? Ooh, this one looks a little bit more difficult. Do you think you could work this one out? Well, of course you can. You know why? Because you would have taken the time to understand the foundation, and now it's all a matter of application. So we need to find this angle. And they only give us this one. But they tell us that BC and AB are both tangents. And if we look here, we would realize that the radius connects to the tangent here, which makes this angle how much again? 90 degrees. And the radius connects to the tangent here, making this angle also 90 degrees. And what shape is made? Well, if you're not too sure what shape is made, let's count the sides as we join the shape. So we go from A, so that's 1, 2, 3, 4. It's a four-sided shape called a quadrilateral. And the sum of the interior angles in a quadrilateral add up to 360 degrees. So if you know this angle is 106, you know that this angle is 90. You know that this angle is 90. So far, we've accounted for 286 degrees of the interior angles, which means the remaining piece must be the difference between 360 and 286. So let's go 360 minus 286. If you're not too sure, you work your numbers, you get 4, you get 2, you get 7. Your answer should be 74 degrees. No hard mathematics. All we did was apply our rules and simple arithmetic. Let's take another example. We're told that AB and AC are tangents, and we're told to find this value inside of here. How do we do this one? Because now they give us no value within the quadrilateral. As you can see, it's the same quadrilateral from last time. But now they give us this angle being 10 degrees. And this is where our previous knowledge comes into play. How are these two angles related? Well, because these two are straight lines, or straight line segments, because they're part of lines, it means then that these angles are vertically opposite to each other. And vertically opposite angles are equal. So if here is 10 degrees, it means that here is 10 degrees. If here was 25 degrees, then here would be 25 degrees. If here was 45 degrees, then here will be 45 degrees, because these angles are vertically opposite. Now, just to jog your memory, vertically opposite doesn't mean that it has to go up, down. It doesn't mean this as vertical. It means that they're directly opposite to each other when we're looking at the angles. Similarly, side note, these two angles are also vertically opposite to each other. So, now let's continue. So we found that this one is 10 degrees. That degree symbol looks a little too big. There we go. Now let's go again. A tangent and a radius, 90 degrees. A tangent and a radius, 90 degrees. So we know that when we add up these four values, we are to get how much? 360. So 90 and 90, 180. 180 and 10, 190. And then 360, take away 190 is 170. So the angle here will be 170 degrees. Again, remember, the rules are important. Know why the answer is the answer and not just what the answer is. Ooh, here we have one that looks like fun. So we're asked to find all of these missing angles. Now, there are so many ways to solve this. Now, let's use one of the rules we remembered from the last slide and see if we can apply this to make our solutions much faster. Well, here we have a line. And what special line is this? That's a diameter. And here we have another line. And what special line is that? Well, that's another diameter. But what that means is that these two angles are vertically opposite to each other. So it means that C is 42 degrees. Now watch this. I'm going to draw two triangles here. So here's this triangle, this one in red, in blue, sorry. And let's draw the next one in red. What do we know about those two triangles? Well, from here to here, that's a radius. From here to here, that's a radius. So this type of triangle is an isosceles triangle. And what about the blue one? From the center to the edge is a radius. From the center to the edge is a radius. So here we have another isosceles triangle. And because these lengths are the same, and the angles here are also the same, then these are congruent triangles. Which means if we find one of these values, then all of these are going to be the same. Because we know that the base angles for an isosceles triangle are equal. And because these are the two same triangles, just oriented differently, whatever value these are will be the same values that these are. So we know that the base angles are equal. So the sum of A and B will be the remaining after we subtract 42 from 180, and that's 138 degrees. And since they are equal, it means that one of the values will simply be half of 138, which is 69 degrees. So that means that A will be 69 degrees, B will be 69 degrees, and why? Because base angles of an isosceles triangle are equal. And similarly, E will be 69 degrees, and D will be 69 degrees. Why? For the same reason. The base angles of an isosceles triangle are equal. See, mathematics isn't hard. It just requires practice. But we will get there. How about this one? And I like this example because it still applies the rule that we were looking at, even though it may not look the same. Look at this triangle right here. That's a radius. That's a radius, which means that what type of triangle is this? An isosceles. So if this is the base angle, it means that C automatically is going to be 70 degrees because the base angles in an isosceles are equal. And if C is 70 degrees and this is 70 degrees, then D we have already found. D would be 180 minus the sum of those. 70 and 70 is 140. So it's 180 take away 140 is 40 degrees. You see how fast the math's becoming easy? That's because we're applying our rules and understanding what they are. Now let's go to this one. We have this triangle. And again, what kind of triangle is this? An isosceles. So here we have one radius. Here we have another radius, which means that if here is 28, how much is here? 28 degrees, because the base angles of an isosceles triangle are equal. So A will be equal to 28 degrees. So then how much will B be? The remaining. So 28 plus 28, as we already know, is 56. So we could do 28 plus 28 or 28 times 2. It means the same thing. Remember that. So the remaining will be 180, take away 56, which is 124 degrees. So we found A to be 40. We found B to be 124 degrees. Now we've already found C and we've already found A. What about E? There doesn't seem to be any chord relating this or any triangle that we know of. But if we notice, that's a straight angle, which means that when we add up those three angles, we should get 180 degrees. So let's go. 124 plus 40 would give us 164 degrees. So we know 164 plus E, whatever value that is, should give us 180. So E should be the difference between 180 and 164. How much is that? That's 16 degrees. So E is 16 degrees because the sum of angles along a straight line will be equal to 180. Again, no hard mathematics here. But as you practice, you will get the hang of it. Feel free to take an example and to go through it. If you want, see all the rule that applies. See how many rules you can find. I might be showing you some, but I am certain you will be able to find more than I am showing you here. What about this one? Here we go again. What shape is this? That's an isosceles triangle. So if here is 50, and these are the radii, it means that A will be equal to B because the base angles are equal. And how much will that be? Well, 50 from 180 gives us 130. So that means that A will be a half of 130, which is 65 degrees. So here we've solved that one already, and we know that here is 65 degrees, and also here is 65 degrees. Now we have to find C and D. Oh, but how do we find that one? Is there any other shape here that may involve the angles we already have and the angles we want to find? How about this one? A shape with 4 sides, called a quadrilateral. But not just that. Where are the vertices located? Well, one is on the circumference here, another one on the circumference there, another one on the circumference here, and another one on the circumference there. All 4 vertices are on the circumference of the circle, which makes this quadrilateral a cyclic quadrilateral. And what did we learn about cyclic quadrilaterals? Opposite angles in a cyclic quadrilateral are supplementary. So that means these 2 angles in blue, circled in blue, those will be supplementary, and these 2 angles circled in red would be supplementary. So that means that if we were to add A and D, they should add up to 180 degrees. But we already know what A is. We found that earlier. A is 65. So 65 plus D is equal to 180 degrees. So how much will D be? That will be 180 minus 65, which is 120. Oh, I'm sorry. That will be 115 degrees. Yes? Now what about the others? Well, we already know this is 115. So just write that there for now. Similarly, the opposite sides of the cyclic quadrilateral, when we add the angles there, they'll add up to 180 degrees. So that means that 55 plus C plus B, because this angle here on a whole is C plus B. When we add those together, that will be equal to 180 degrees. But we already found what B was. So 55 plus C plus 65 is 180. Well, we add like terms. Remember that from algebra? Add like terms. 55 and 65 is 120. So 120 plus C is equal to 180. So that means that C would be equal to 180 minus 120, 60 degrees. Again, with practice, we'll be able to answer and solve our various questions. So let's look at this example. We see so many lines, we see so many shapes, but let's break it down to what we know again. Well, we have these angles being formed. So we have 50 being formed here. And what shape involves 50? Well, that is a cyclic quadrilateral. Sometimes it will take time for you to be able to see the shapes, but as you practice, it will become easier as time goes along. Well, what it then means is that the opposite sides, and let's put them in green this time. So this 50 and this angle will add up to how much? 180 degrees. So let's do that in the meantime. 50 plus this angle. Now what's this total angle? This total angle is 60 degrees and also this D angle. So that will be 60 plus D. And when we add up those, we will get 180 degrees. Now 50 and 60 we know is 110. So 110 plus D is 180. So that makes D 180 minus 110. So D angle is 70 degrees. Let's write it in. Again, we're writing our answers in blue. So here is 70 degrees. Nice. Now what do we know then? Well, if here is 70 degrees, what shape is this? This is an isosceles triangle, which means that the base angles are equal. So if D is 70 degrees, then E is 70 degrees. And we can go back and forth to our same cyclic quadrilateral, because now this angle and that one, they are opposite each other, which means that they are supplementary. Angles opposite each other in a cyclic quadrilateral are supplementary. So it means that if we were to add A and E together, they would be 180 degrees. But we already saw that E is 70. So that means that A would be 180 minus 70. That's 110 degrees. We're making progress. We're making progress. So let's continue. So here is 70. Here is 110. Is there any other shape that we can see? But of course, we can find C. Because if here is 70 and here is 70, and we already know that this is an isosceles triangle, it means that C must be the remaining from the 180 degrees. 70 and 70 is 140, and 180, take away 140, will give us that this angle here is 40 degrees. Let me write that over so that it will be clear. 40 degrees. And what is this? That's a straight angle. So that means that C and D are supplementary. So if here is 40, then this angle will be 180 minus 40, which will be 140 degrees. Now we have to find these missing angles. And there are, again, different ways in which we can do this. Now, I'm going to do one, and I want you to be able to determine what is a different way I could have done it. So let me do one. So I know that B is 140 degrees, so let me just erase this a little bit here so that you can see what I'm talking about. B, we've established, is 140 degrees, and we've established that C is equal to 40 degrees. Yeah? Now we have to find F and G. And F and G are both angles in what is that? That's an isosceles triangle. And we know that this angle is 40 degrees, which means that this angle is 40 degrees because these are vertically opposite. And the base angles of an isosceles triangle are equal. So if they add up to 180, it means that F plus G must be the remaining, which will be 140 degrees. So that means that G will be a half of that, and F will also be the same half, so that's be 70 degrees. Here is 70, here is 70. Is there a different way we could have done that? But of course. And let me just show you one. What is this? That's a cyclic quadrilateral, which means that the opposite sides are supplementary. So since this is 110, 110 plus how much will be equal to 180? 110 plus 70. Again, when it comes to circle theorem, it's all about the practice. Say your reasons as you get each angle. That way, you will be able to understand why the answer is and not just what the answer is. We're not just making you what people, we're making you to solve problems. And to solve problems, you need to be able to answer Why? How about this one? Well, we have to start again from the angle we know. And if we trace it back, we realize that the invisible chord here, and I'm going to draw the invisible chord in, is subtending that angle. And any angle subtended by the same chord at the circumference in the same segment will be the same. So if here is 25, that means this angle is also 25 degrees. You know what? Let me change the color so that you're able to see what I'm talking about. So I'm drawing the chord in red. You see that this chord is subtending the angle 25 at the circumference, and it's also subtending the angle B at the circumference in the same segment. So that is why we're saying that B will be equal to 25 degrees. Now, what about A? A is also being subtended by the same chord. But where is A? A is at the center. And what is the rule between angles subtended at the center and angles subtended at the circumference? Well, if the angle subtended at the center by a chord is always twice the angle subtended by the circumference of the same chord. So since the angle at the circumference is 25 degrees, then A would be twice, or 2 times 25 degrees. A would be 50 degrees. Yeah? How about one more example? Just one more. How about one more? Here is this fancy looking one, but again, the rules do not change. Let's look for the angles we want, and let's look at the angles we have. Well, we have 20 being in this corner here. But do we know anything about that 20 just yet? No, because this 20 is between the center and the chord. Okay. You know that this angle here is 210. Now this angle is the reflex angle because it's the larger angle, it's the angle on the outside. And it's being subtended by this invisible chord. C is being subtended by that same chord. And remember, when we were doing the rules, I gave you an example that looked just like this. To show you that this angle subtended at the center, it being on the outside, will be double the angle subtended at the circumference on the inside. So it means that C will be equal to a half of 210, which is 105 degrees. Now, let's erase that extra. What about E? Well, B, from A to B to C to D and back, that's a cyclic quadrilateral. So the opposite sides are supplementary. So if C is 105, then E will simply be 180 minus 105, which is 75 degrees. And all that's left to find is D. Well, we can look at the fact that this shape is a quadrilateral, and as a result, if we wanted to, we can add these 3 numbers together and then take that away from 360. But I want you to look to see if there's any other way we could have done it. And I'll leave that one for your homework. So let's do this one. 210 plus 20 plus 75. When we add those numbers together, how much do we get? We get 305. So it will be 360 minus 305, which is 55 degrees. And I know some of you all would have looked at it before and say, well, D is 20 because this side is 20. Do not do that. Do not work mathematics. We are working mathematics. Let us follow our rules and solve our questions. One more. We can make one more. Let's try one more. And we'll end with this one. How are we going to determine the angles here? Do you see? Can you see? Well, let's start with what we know. Here, we have this angle 47. And this angle is being subtended by what two lines? This line here and this line here. Now, what is this line? This line coming through the center, this is the diameter. And we know that that is a triangle. So that means that this angle, because it's being subtended by the diameter at the circumference, this angle here will be 90 degrees, which means that x will be what is remaining. So 90 and 47 is 137 degrees. What angle will make it 180? We subtract. So we get 43. So this angle is 43 degrees. Now, let's look again. Now we need to find y. And how can we find y? Well, let's see what chord is subtending y. So let's trace back from the angle. And we realize that this chord is subtending y. Well, is that chord subtending any other angle? Yes. It's subtending x. So, because they are subtended by the same chord in the same segment at the circumference, that means that y will also be 43 degrees. So if you want additional examples, you can go onto the Division of Education, Innovation and Energy's website, or you can search for them on Google. They are readily available examples, and I encourage you, continue to practice, continue to try. The more you practice is the more the rule will become embedded into your mind, and you'll be able to see the patterns that you thought you may have never been able to see before. Until next time, I am Mr. Atwell, and do have a wonderful rest of your week.